Can you hear me now? Good. All right, great. So just straight on, get into the project. Essentially, Everyone TV reached out to ITV, one of our clients, and said, hey, we're building an app. We're going to partner with TV manufacturers and ship it with it. We want you to build an API so our users can watch live TV. Essentially, what they were saying is, can our users watch Love Island, please, live? So, as is any software project, it was a journey of deadlines and quick iterations, hopefully. So, we start with requirements. Of course, we have many, but I just picked the interesting ones. So, scalable. So, usually with live TV, you have pretty much not much activity, but then you have a burst of around peak time. So, we want to be able to handle that. Low latency. So, when you channel surfing, you don't want to wait 5 seconds for a channel to show up and watch the feed. Platform agnostic, a bit strange. We'll get back to that later. And of course, meet the deadline. So yeah, hopefully go fast and hopefully don't break anything. So how do we go about building it? Well, spoiler alert, it's serverless. So the first milestone is return just one channel. We just wanted to get something up and running. We were a small team. We started with 2 engineers and we needed Everyone TV to have something to be able to test and use on their TVs. So what we did is we basically had a very simple Route 53 pointing to API gateway and a Lambda that just returns a channel. Okay, so the journey begins, fast iterations, new requirements, more features, and so on. So we kind of ended up with something that looks like this. So we have, of course, at the top here, in front of the API gateway, we have a WAF, we want a rate limit, we want a geo-block, because no one outside of the UK should watch our content, sorry, the rest of the world. We added MTLS later down the line with API gateway, so only approved manufacturers who are working with Everyone TV can make call to our API. Of course, we built the Lambda with Go, and we've used parameters and parameter storing secret extension parameter. Secret manager extension. And of course, we did a lot of observability and CloudWatch metrics and stuff, but I didn't include it in the architecture, but we did that. So, features so far of the API, we kind of have URL signing, which does some HMAC encoding, so it does some cryptographic stuff. We handle our user authentication ourselves, so we didn't use like Lambda authorizer or any API gateway. I think V2, I got told yesterday, it can do JWTs for you, but we handled it ourselves on our Lambda. And with that, we were able to get personalized ads. So if someone's watching the stream and we can get a user ID from it, for example, we can personalize the ad for them. And of course, we used MTLS to make the API a bit more secure and only approved devices can reach out to it. And of course, there's some more compute of DRM and licensing happening on the Lambda when every request comes through. So to protect the content and so on. So, how is using AWS Lambda platform agnostic? Well, we kind of chose AWS because we were pretty familiar with it, and we kind of had a requirement of like, we might potentially use another platform. So, kind of how did we go about to at least make sure our code doesn't live in the AWS world and uses AWS specific things? We use something called an AWS Go API proxy. Essentially what it does, it takes an API gateway request or an ALB request and then transforms it into a HTTP standard API request. So then our API logic can just be a normal HTTP API server. And to showcase that in practice, here you can see the handler. Sorry, this is Go, if you're not familiar. Essentially, when someone goes on the / endpoint, this code will handle this request, and then it will just return a hello. And all we do is just pass it through the HTTP adapter, and then Lambda start, and then we don't care if it's an API gateway request or an ALB, it should happen. So, I guess we can talk about a bit our learnings of going down this path and kind of what we learned from it. So developer experience was pretty good. Like I didn't have to mock any events or use any local stack and spin it up locally to test my API. I can just spin up an API. I can even containerize it and spin it up and just run the tests against it. So fast feedback loops and get immediate feedback when developing locally. So thank you, HTTP Adapter, for that and the library. And then, of course, as with any software project, setting up the foundations is very important. So making sure you can test locally and be able to be confident. Setting up AWS Playground environments and ephemeral environments so you can just spin up your infrastructure. While you're confident locally, you also want to see it running in the cloud. Spin it up and spin it down, of course, so you don't spend money on testing stuff. And of course, set up a robust system of CI/CD so your iterations are, as your features are coming in, your tests are running, linting and everything like that. And it's all streamlined and goes to production. And of course, a few platform learnings. Of course, this one is for AWS. MTLS was not easy to do. Turns out we had to talk a few times to AWS and kind of clarify a few things, but yeah, it was a bit of a pain point. And also we used the AWS Parameter Store and Secrets Manager Lambda extension. While it does work, I'm not really a fan of it, and you'll see in a bit why. So I know when everyone said is show me the numbers, you build an API that on serverless that kind of gives a live TV feed. So what's your latency like, bro? Okay. So are we fast and scalable? Well, yes, we are. I guess I wouldn't be here if we weren't. But yeah, we usually get minimum 300 requests a day. And of course, we don't get it like all in once. Again, we have peak times. So when I check last production and as devices are being sold, obviously the usage is going to go high. But we usually have 30K requests on a 5-minute ramp up, and then it can go up to 60K requests. And of course, the cold start time there is 400 milliseconds, which, hold on, it's double the latency target that you wanted to hit. Well, yes, but remember I said the Secrets Manager extension? Well, that's most of the latency is making a call to Secrets Manager, getting the secret, and then starting up the Lambda. So yeah, overall, when the Lambda is warm, which is most of the time anyway, because people flick through the channel surf and on their TV, and you have a Lambda warm anyway. So yeah, on average, it's 35 milliseconds response. In fact, I checked, and I was quite surprised. The Lambda takes 4 milliseconds to execute on a request. So the rest is all the integration latency and API gateway and so on. So looking into the future and kind of going back to platform agnostic. So there's no such thing as platform agnostic, in my opinion. It's always a trade-off. So the trade-off we've looked to take here was to change the infrastructure around it while keeping our API code kind of the same. So no matter where we go, we can containerize it, we can use another platform, we can use another CDN provider, or whatever it is. We can take that code and just change the infrastructure around it and be able to deploy it. And yeah, we're exploring edge computing, and probably, I think Cloudflare talk was pretty good with some of the stuff they were doing. So yeah, thank you very much. That was it. And if you'd like to connect, go to my website. I have all my links there. Thank you.